Alright guys, let's see what we got today. Okay. Minimum jump to reach end via prime teleportation. Okay, let's, you know what, right from now on I'm gonna start using pen and paper. Oops. Water. Okay. So once I solve it on my book, on my notebook, I'll try and see if I can explain you guys on the LeetCode website that I use. Okay, let's see what are we given. We're given an integer array of nums, okay, and character and integers, and we start from 0, and our goal is to reach the end. For any index I, you may perform one of the following operations: adjacent step, jump to index I plus 1. Okay, so we could go either from 1 to 2 or 1 to, well, if it's out of bounds then no. And then if I have a prime number, you may instantly jump to any index where j is not equal to, where the index number is different but the prime number is divisible, modulus of the prime number is divisible. So for example, if I have 7 prime number, anything that is divisible by 7, for example if I have 70 further on, right? So for example in 1, 2, 4, 6, 1 is a prime number. Is 1 a prime? I forgot. 1 if 2 is a prime, therefore we teleport into index I equal to 3. 6 is divisible. Let me confirm, I forgot. 1 is prime. Okay, so 1 is not a prime number. I forgot basic maths. Okay, so what are prime numbers? Okay, so 2, 7. So is there a range given? I could have up to 100,000 points. Okay, 100,000, 10 to the power of 5 characters. And then I could have up to 1 million numbers, 1 millionth integer value. Okay, so since nothing is 5 is prime, but there's no divisible, so device is divided by 5, so may perform any 2 actions. Okay, so how do we go? Do we keep, maybe we have something called a is prime function, right? So if I have a list of, let's say 1, 2, 4 and 6, we are given, we have to start at index 0, right? Index 0, 1, 2 and 3. Start is always at index 0. Then either we could go position 1 or -1, right? For 0 we could only go 1, so jump to I plus 1 or I minus 1 if the index is within bounds. Okay, if the index is within bounds, alright. But why would we ever go backwards? That's my main. Why would we ever go backwards? Let's write it down. Why ever go backwards? Right? So let's say from I equals to 0, which is 1, I go forward to I equals to 2. I check if 2 is a prime number. What would be is prime number is a, how will I check in Java if an integer is a prime number, if it's divisible by itself? How do I check if something is a prime number? How do I check if something is a prime number? If the prime number divisible by itself has a divisor 1, right? For example, if I have 4, if I have 2 divided by 2, and then the divisor is 1, remainder is 0 and divisor is 1, then that is a prime number, right? For example, if I have 7, or let me have 13, if I divide 13 by 13, what if how will we decide? Okay, so 2, 3, 5, 7. 11 is also a prime number. 111. I don't know, there could be a lot of prime numbers, so we need to find. Okay, so what are we doing? We are traversing from 0 to n minus 1, right? Here we go from start to the end, then allowed to go 1 ahead or 1 forward step and 1 forward or 1 backward step, right? You may perform one of the following. For any index I, jump to I plus 1 if the index is within bounds. Okay. If it's a prime number, you may instantly jump to any index that is different index such that num okay, let's see. Use a breadth BFS. So pre-compute prime factors for each number I via a sieve. How do you and build a bucket by mapping each prime to all indices during when at index I all indices. Let's be from dividing not clear. Path can be really, we can go 7. Okay, so how do we create a factor? So use pre-compute prime factors in a sieve. Build a bucket mapping prime p to all indices. Okay. So what we're given is pre-computing prime factors for each number. So for each number in nums bracket I, we build a bucket for each nums bracket I, right? We build a bucket which maps each prime p to all this is j. So what does this mean? For each value we check the prime numbers. Okay, I need some how am I thinking? Start at 0. I think goal is to reach index n minus 1. Okay. So for each bracket we build a bucket which maps prime numbers. How do we build a bucket? So example, let's say if I had build mapping each prime p, and I build a bucket array p mapping prime p to all the indices j, where I don't know, how do I, let's see. Understood the question, but begin or it's because of cost, exactly, yes. Then all edges have equal cost. Stuff. Okay, think of indices as graph nodes. So the indices are 0, 1, 2, 3. Adjacent moves create edges. But teleport adds at index 1. Right, factor 2 is prime. So from index 1 you can jump to any index whose value is divisible by 2. Right, so index 1 has edges. What? Extra edges 2 or 3. First for each index check if the edges can do that becomes a. To says build a bucket p for all indices whose number index. Suppose if our then prime 2, because 2 is divisible by 2, for prime 3, prime 7 during if you're at index 1. So basically you just do bucket dot get. Instead we get options. That's the trick, but how do we build buckets prime? For example, 12 equals to prime factors are 2 and 3. So bucket 2. This is where sieve slash preprocessing, you don't actually need to code it here, just consider for every number, and then for each prime number p. What is the index for each index? Scan the okay. So first is you compute all the prime factors. Right. Prime is I think you should try coding. Just can you build? Okay, let's try to build. Okay, let me have public static what map of what integer comma a list of get list of teacher this is start public static map of in teacher comma list of an teacher bucket. Right. Okay, let me have gen equals to nums dot length equals to new hash map or we have a static block, right? Right. Hash map. So what I will do is for each value, for teacher number in for each nums, right? If num is prime, add that to the map, and then we also add the indexes where it's a factor. For every index. Okay. First of all, for every index I find the prime factors. Right. Okay, so for every, so we have to find teacher I equals to 0, I must be less than n, again I plus plus. Right, we create a list of and teacher get factors equals to get prime factors of nums bracket I, right? To see private array get prime factors. What does it take? That takes an integer I. Okay, so we have something called get prime factors. Now do we get prime factors for each integer? Well, we have factors list of teacher and array list, right? And then so while I is list dot add, so if I is 3, let's see, I need to find the factor number. So for example 2. p create teacher so if we are to remove copies use okay. So for each prime factors, right, and then we create a list of factors for each value. If x modulus d equal to 0, then x equals to x divided by d. Okay. Suppose x was 12, so without the while loop. So equal to x modulus d. Okay, so what we have to do is for what we have integer d equals to 0, d star d must be less than equal to x, and digits plus plus. If the number modulus d equal to 0, we do factors dot add d, and then we do while x modulus d equal to 0, x divided equal to d, right? So this will remove the factors, and then if at the end if x is greater than 1, factors dot add x return factors. Okay, so but when we do x is x is 2. Okay, yes. Okay, d should start at. Okay, inside we do computer factors, but so what do we do factors? Bucket, right? So for integer p, so each factors, do we do bucket dot compute if absent p, and then we add new array list, right, dot add value of I. So if I have 2 3, I add 2 and then example 2 3 into 2 is added at 0 and 2. Okay, so now this is completed, right? So compute if absent has to be capital. So you need teacher. Okay, let's solve. So what's happening here is we connect everything by at this. Okay. Okay. So we create a queue from teacher q equals to new linked list, and then we create a boolean array visited. So new boolean array of size n. Initially we keep everything as visited. Q dot offer 0 and visited bracket 0 equals to true, right? And then we create an integer equals to 0. So what do we do? While our q dot is empty, oh yeah, Boolean spelling. Boolean array. Q is not empty. But when we initialize q only at for 0, that means q has one element at the beginning. we're standing only at index 0, then integer size equals to initially q process equals to while q is empty, is not empty, and while q is not empty, integer size equals to q dot size. Right, we got the number of elements. I equals to so we do integer size equals to q dot size. Okay. So we have this, and then what are we doing? We are looping for integer s equals to 0 and s must be less than equal less than size, right? Then s plus plus we do integer I equals to s q dot poll. Q dot poll means we pull that item if I equals to n minus 1. That means if we reach the end, we return jumps, right? If I minus 1 is to 0, is not visited bracket is 1. If I minus 1 is greater than, then we make visited of this 1 equals to, we make it visited, and then we do q dot offer I minus 1. If I plus 1 is less than n and is not visited of I plus 1, right? We do visited bracket I plus 1 equals to make it visited, and then we do q dot offer I plus 1. If bucket dot contains key of what nums bracket I, then for teacher next in bucket dot get nums bracket I. So we loop through all the index positions, right? And then we check if it is not visited bracket. Well, if the is not visited, we do visited of next equals to true. We make it true, and q dot offer next, and then bucket dot remove of nums bracket I, do it jumps plus plus, and everything happens return minus 1. q dot offer function goes to the what for the list of indexes. Just adds an element in q at the back of the so it will be plus any problem you are storing indices not value secure. Q becomes 0 meaning start. Meaning process. Okay. As we explain with an example, this is working. So teleport to number 1. So in shifts we use nums preprocessing, we factor nums 0 equals to 1, then nums I equal to prime, nums 2 equal to 4, which is so for bucket of 2 becomes 1, 2 and 3 right here. So level 0 we process all nodes currently in queue, only index 0. So size is 1, processing I equals to 0, queue becomes queue size is 1, queue becomes equal 0 is not equals to left is invalid, then we go right if I plus 1. Yes, that is true. Okay, that's not visited, then we make teleport num 0. So level 1 jumps is equal to jumps plus right, process I equals to I equals to 1. Do I have okay, so after the first loop or check when I to 0 where does I clean for check. Index take it from queue. Okay, so what happens? Give me the next index for taking queue. Next. Let's see how did this guy do it. Bro, these problems, I don't know. I think I need to learn some queues and graphs and that stuff. I haven't worked with those as much. I don't know. I have to study this again, bro. Okay, I'll see you guys again.